recap a little bit what we have looked at into this topic for a fuzzy set. Last week we already covered some introduction, what are fuzzy sets mean, how to represent fuzzy sets, and some properties of fuzzy sets, right? Okay, and then we also looked at the membership functions and some properties. Okay, and properties ni ingat lagi, we looked at equality, inclusion, cardinality, empty, and alpha cuts fuzzy sets. So these are the things that you've done in your tutorial yesterday, and you also looked at how to represent the fuzzy sets using the membership functions. So, and we also already looked at hedges, uh, which actually strengthen the shape of a fuzzy set. Okay, and also all of these functions. So for today, we are going to look at the next part, which is fuzzy set operations. All right, so we are going to look at how we do some operations, which we usually do in classical sets. Yang classical set ni macam Venn set yang you belajar dululah dalam mathematical kan, matematik modern dulu. Okay, so when you have several sets and it can be intersect with each other and it can contain of each other. So there are these operations, and we can also do this with fuzzy sets. However, the process of these operations onto fuzzy sets will be a little bit different, as it involves some membership function. Okay, sebab definition of classical set dengan fuzzy set pun berbeza kan. When we talk about classical set, we always talk about which element belongs to which set. But when we talk about fuzzy sets, it's always about how much does this element belong to the set. Okay, so it has different meanings. So when we do some operations onto it, so the operation will be a little bit different. So you can see in this slide an example, a complement. If this is an A and this is not A, okay, the gray area is not A. If this is a containment, A is contained in B, so A is a subset of B. Okay, intersection is A and B, yang mana bersilang, and then you have union A or B. Okay, so it united every single element in A and B. Okay, and then we look at fuzzy set. How does it look like? Okay, when you use fuzzy set, we always look at the membership graphs. So when it is drawn in the graph, so you have to see that the fuzzy set has been changed, so it will look a little bit different. Contohnya, if you see the set A yang tiga segi ni, okay, when you try to complement it, complement mean is not A, so it is actually the inverse of the set. So dia terbalik, tiga dia akan terbalik, because 1 becomes 0, 0 becomes 1. Okay, kalau dekat elemen yang sini ya, this is one element, for example, if it is belongs to A as 0, so it belongs to not A sebanyak 1, so dia akan jadi terbalik lah. Okay, and then containment is inside of it, yang A yang duduk kat dalam ni, so B yang kat luar. Same goes here, A yang kat dalam, B yang kat luar. Right, A and B is the intersection, and A or B is the union. We will look at this operations one by one. Okay, we start with the complement. Boleh nampak slide kan?
Boleh,
Okay.
madam.
Boleh, madam.
Alright, good. Okay, so bila kita describe a membership function, a membership value in fuzzy, we always use mu AX. Macam mana kita baca yang ni? Mu not AX. Maknanya mu ni is the degree of membership, X is the element, yang kecil bawah tu not A is the set that you are going to describe. So kita nak tengok how much does this X belong, how much is the degree of membership, okay, how much does X belongs to this set, not A. Okay, kalau you tengok this kind of function, itulah maksud dia. In this side, kita tengok how much mu, how much X belongs to A. Okay, so how do you calculate this? Biasalah kalau complement, biasanya ialah 1 minus. So how much the degree of membership here, 1 minus the degree of membership will say how much it belongs to the not set. Okay. So tadi macam contoh saya kata, elemen yang sama dekat sini, tengok pada graf elemen dekat sini dia bilang kepada A sebanyak 0, so it belongs to not A sebanyak 1 minus 0. Okay, so equals to 1. Faham Kalau another element, if you see another element here, for example, dia belongs di A katakan 0.5, maka dia akan belongs to not A sebanyak 1 minus 0.5. So dapat sama 0.5 and so on. Is it clear?
Clear, William.
Yes.
Okay.
So maknanya bila fuzzy set, kalau kita selalu sebut, kalau dalam classical set, not ni complement ni is more to describing which element does not belong to the set. But in fuzzy, we are not talking about does not belong. We're just saying how much does the element not belong to the set. How much? It's not about do you belong or not. Okay? It's more on how much it belongs to not the set. Okay, that is complement. Right? So for example, if you are given a set for tall men, you can see here, tall men ada berapa elemen yang dia senaraikan tu? 180, 182.5, 185, 187.5 and 190. Tu dia punya elements And the degree of membership yang kat depan tu. 0, 0.25, 0.5, 0.75 and 1. Okay, that is how much each element belongs to tall men. So kalau kita nak cari set not tall men, so kita kena complementkan lah, right? So we have to negate the statement. Kalau not, it means that the degree of membership will be 1 minus belongs to the set. So 1 minus, if you look at this one, okay, 1 minus 0 is 1. 1 minus 0.25 is 0.75. Okay, 1 minus 0.5 you'll get 0.5. 1 minus 0.75 you'll get 0.25. 1 minus 1 is 0. So dia punya set akan jadi terbalik kalau you imagine the graphs. So the graph will be upside down. Okay. And next we move to containment. Containment is similar to a Chinese box or Russian doll. Pernah tengok Russian doll? Can you imagine what is a Russian doll? Kan? Russian doll tu patung yang biasanya colour merah. Bentuk dia simple je. Russian doll tu. Biasa dia macam tu kan. Lepas tu dia ada boleh buka, masukkan dalam dia masuk lagi satu saiz kecil sikit. Lepas tu dia ada kecil lagi kan. That is a Russian doll. So maknanya yang kecil itu dia akan jadi subset of the bigger one. Because the smaller set will be the subset. Right? Yang the bigger set kita panggil apa? Kalau the smaller set kita panggil subset. What do you call the bigger set?
Set.
Set? Sure? Yang besar kita panggil superset. Superset. Maksudnya superset tu yang besar. Subset yang kecil. Okay? Alright. So subset is the set that is smaller that contains inside the superset. Right? So macam dalam case yang ni, contoh, kalau saya tengok yang first ni, A is the subset of B. So B is a superset of A. Okay? Tapi jarang guna perkataan superset tu. Saya ingatkan you all pernah dengar. Pernah dengar ke tak sebenarnya?
Pernah. Tapi tak selalu guna.
Sebab tak selalu guna. Kita lebih fokus kepada yang the smaller set inside kan. Sebab the superset biasanya dia besar and it is usually generic. Bila dia general, kita tak nak dah tengok semua elemen, it's too big. So usually we focus on the smaller set because we want to see which set is actually belongs to another set. Okay, so in fuzzy set, the same thing lah. Kita kata which set belongs to other set. Right, contoh macam ni. Kalau kita tengok dia punya degree of membership, kalau you tengok dekat dia punya line tu pun, A is subset of B if semua degree of membership A tu mesti less than B. Okay, dan dia berada di dalam set ni. sini. So dia akan berada di dalam. Bila dia berada di bawah daripada set yang superset dia, maka kita boleh katakan that set is a subset of the other set. Okay. So in fuzzy, dia punya containment tu, dia mesti semua elemen yang ada dalam subset tu berada di dalam superset. Okay. Ni dekat sini you baca ni. Universal X. Kenapa saya macam saya dah cerita benda ni? Saya rasa macam dah cerita baru last week Tak cerita ke?
Last week is the properties.
Belum lagi.
Benda lagi
Lebih kurangkan.
Lebih kurang sama. Tu lah rasa saya pernah tengok pula. Okay. In containment, we look at this universal X, maknanya semua elemen in X, okay, mesti ada dalam the superset. And kalau kita kata A is a subset of B, so dia punya degree of membership mesti always smaller. Right? Sebabnya kita nak kata dia punya graph tadi, kalau kita tengok graph, katakanlah yang luar ni B, A dekat sini. Okay. So dia punya degree of membership dia sentiasa, kalau kita tengok kat sini, dia sentiasa less than B. B yang ke atas kan. So if every single element fit this situation, so kita kata dia adalah subset. Right. Look at the set given to you. Contoh kat bawah tu. Okay. For A, kita ada elemen 1, 2 and 3. Okay, dia kata X ni adalah 1, 2, 3. X adalah dia punya universe of discourse. Maknanya semua elemen ada 1, 2, 3. So 1, 2 and 3 belongs to A, and 1, 2 and 3 also belongs to B. Right? And the degree of membership, 1 belongs to A, 0.3. Yang ni. 2 belongs to A, 0.5. 3 belongs to A is 1. And 1 belongs to B, 0.5. 2 belongs to B, 0.55. 3 belongs to B, 1. Jadi, the degree of membership, if you look here, for each of the element is always less or equal to. Okay? So, disebabkan itu, we can say that A is a subset of B. Clear?
Clear, madam.
Alright. If we are clear, we can move on to the next one, which is intersection. Okay, so for intersection, kalau dalam Chris set biasa, gambar ni salah lah. Ini containment punya gambar. Okay, gambar ni kita refer pada gambar yang atas ni lah. This one gambar tu salah. Okay, for intersection, when ada dua set yang bertindih, contoh kalau intersection dalam Venn set biasa yang ni kan, this is A and this is B, A dengan B bertindih, di mana dia bertindih itu kita panggil persilangan, itu we call it intersection. So that is A and B, yang mana it fits the property of A and B. Okay, both true baru dia true kan, so dia duduk dekat tengah-tengah tu. So for fuzzy, kita ada intersection when set graph dia bertindih di sini. Okay, so intersection dia yang ni, sebab tu dia dapat bentuk ni. Okay, so kita panggil dia A and B. Apa kriteria dalam intersection? Okay, untuk kriteria dalam intersection, okay, for every element, okay, untuk A and B, degree of membership dia mesti minimum. Okay, minimum of how much X belongs to A, how much X belongs to B. Okay, so kita cari dia punya minimum, then the minimum value will be the degree of membership for X belongs to set A and B. Alright, contoh dekat sini dia bagi dua set, tall man and average man. Dia ada elemen 165, 175, 180, 182.5, 185 and 190. Elemen dia sama ada dalam set satu ni. So bila kata apa, what are the set tall man and average man? This means intersection N. Okay, so kita ambil the minimum degree of membership. So for 165, kita ambil degree of membership dia 0 and 0, so minimum dia 0 lah. Okay, for 175, degree of membership 0 1. Minimum 0 and 1, kita ambil 0. Okay. And then for 180, degree of membership dia 0 dengan 0.5, minimum 0. Okay. 182.5, 025, 025, we take the minimum value, which is 0.25. Okay. 185, the same goes here, 0.5 dengan 0. So minimum kita ambil 0. Yes. 190, minimum 1 and 0 kita ambil 0. Okay. Kalau kita tengok kat sini, jadinya ada satu je elemen yang belong kan. Yang 0 means not belong kan. Jadi dia ada satu je. So graf tu dia jadi lebih kecil daripada graf yang asal. Okay. Clear? Alright. The next one we have union. The union is when we're trying to describe which element belongs to either set, either A or B. Okay. If we're talking about Venn set, if an element is here, it belongs to A or B. If it's here, it also belongs to A or B. If it's here, also belongs to A or B. Betul? Okay. So begitu juga dengan fuzzy. If we talk about fuzzy, kita nak tengok semua elemen yang belong ke dalam dua-dua set. Jadi dia akan cover all graph ni. Alright. So how to calculate the degree of membership? Okay, sama macam intersection tadi, cuma intersection akan cari minimum, while union you use the maximum value. So kalau ada dua value, contoh dekat sini, 165, 175, 180, 182.5, 185, 190. If you look at the degree of membership, untuk 165, 0 and 0, kita ambil 0, sebab maximum 0, 0, 0 lah. Maximum 0 and 1, kita ambil 1. Okay. Maximum 180, 0.5 dengan 0, kita ambil 0.5. And then maximum 0 to 5, 0 to 5, we take 0 to 5. Okay. Maximum 0.5 and 0, we will take 0.5. And lastly, we have maximum 1 and 0, we will have 1. So, dengan union, usually the graph will be bigger. Okay, sebab you combinekan several graphs together. Right, so biasanya bila kita kata some functions is connected with or maknanya dia akan gunakan union. Kalau intersection tadi kita punya description should be macam ni. Okay, yang ini adalah and. Okay, is it clear?
Clear, madam.
Clear.
Right. Okay, so macam so it's clear about how to do some operations onto a fuzzy set. So these operations you will use during your inferencing later. Masa inferencing akan ada banyak rules, and then you fire the rules. Biasalah kan macam you buat dalam knowledge base dulu, you fire some rules and then you get some values. Different values in one rule, you have to combine it together. Kalau rule tu connected by and, dia akan cari intersection lah. Kalau you punya rule connected by or, so you will find the union. Kalau dia kata not, so you kena minus. Okay. Kalau dia kata some hedges like very or extremely, so you have to do some operations on to the degree of membership using the functions accordingly. Alright, so next we are going to look at what are the applications of fuzzy sets and how are we going to come out with the fuzzy set when we have the problems. The example given here is an air conditioning system, aircon. Bila you ada aircon, you need the aircon to always control the blower. You want to control the gas that it pumped into the machine by identifying the temperature and humidity of the space. So dia ada sensor, the sensors to input dia lah. So input dia akan identify temperature and humidity. Usually aircon macam itulah fungsi dia. Tetapi there are lots of different model of aircon. Sometimes aircon dia punya input berbeza-beza, so you have to look at the input lah, apa input dia. Alright, consider Johnny's air conditioner which has 5 control switches. Dia boleh pasang dia punya aircon, sama ada cold, cool, pleasant, warm and hot, right? And then the corresponding speeds of the motor. So it will going to control the motor of the aircon, the fan tu kan. Sama ada minimal, slow, medium, fast and blast. Sama ada kita macam kita nak pasang kipas tu nombor 1, 2, 3, 4, 5 lah. Right? Biasanya kalau yang satu tu setakat dia bergerak je lah, so it minimal. Slow, dia laju sikit, and then medium, faster, and then you have fast, and then blast. Kalau blast tu mula yang you dengar macam kapal terbang nak pecah kan, bunyi dia kuat sebab dia laju. Alright, so these are some examples of the rules governing the air conditioner. Alright, rule 1 says if temperature is cold, then speed is minimal. Okay. Rule 2, if temperature is cool, then speed is slow. If temperature is pleasant, speed is medium. If temperature is warm, speed is fast. If temperature is hot, speed is blast. Tu logik dia lah kan. Kalau temperature dekat luar dah sejuk, cold, so you tak nak kipas tu kuat sangat, so dia pergi minimal. Kalau you perasan dalam aircon kadang-kadang ada you letak auto kan. Betul tak? You letak auto kipas dia, you tak sebut berapa laju kipas. Itulah yang dia akan buat. So kipas dia akan tentukan berapa laju dia nak pusing. Identify the temperature outside and then dia akan pusingkan mengikut kelajuan yang perlu sahaja. So rules dia macam tu. Kalau tak ada rule ni nanti dia punya kipas tu duk pusing laju yang sama je. Padahal kat luar dah beku pun dia laju juga kan. So they have to control it. We want the air conditioner to be intelligent enough to control itself. Dia punya speed of the fan. Tak payahlah kita setiap kali dah rasa sejuk kita nak turunkan temperature kan. So it can be set on auto. So it will automatically set the fan. Okay. So macam mana nak tentukan bentuk graf tu? Tadi you all tengok ada graf kan. Someone is tall, medium, high, average kan. So macam mana kita nak letakkan value tu? Alright, so in this case to set the temperature, kita nak gunakan Johnny's perception. So kalau you nak buat satu sistem, usually you will have your user perception ataupun you will have your expert perception. It depends on the problem. Sometimes for some problem you will have expert. Sometimes for some problems you will need some input from the user. So you maybe need to do some surveys, collect data, and then you come out with the graphs. Okay. So masa you dapatkan value tu, you come out dengan this table. Right, bila you nak come out dengan table, kita identify apa dia punya variable and the value. Variable kita tadi temperature kan? The fuzzy variable is temperature. Kita ada 5 value. Cold, cool, pleasant, warm and hot. Okay. And then temperature ni kita suka dari segi degree Celsius katakan. So you letakkan dalam table dia macam ni. Okay, you letaklah the increasing value daripada minimum dia sampai maximum. Ikut jugalah, in certain country dia takkan sampai 0 pun. Right, in certain country mungkin dia sampai about 16. Alright, they ikut depend. So you have to actually develop the system according to the problem. Kalau problem tu nak cover sampai 0 lah dia. Okay, alright. Lepas tu you letak several value. You ada Y star and N. Okay. Y kalau you rasa yes, temperature tu belongs to that value. Okay, you letak Y star bila yes, this is definitely belongs. Okay, definitely memang dah satu lah, maknanya totally belong. So kalau you sangat setuju yang dia totally, so you letak Y star. Selain daripada tu, kalau you rasa it does not belong, you letak 0. So you bagi dekat customer you, your user. So user dia dekat sini Johnny. So Johnny pun dia tengok, okay, kalau 0 degree, Johnny kata to me 0 degree is yes, it's very cold. So dia letak kat sini Y star. Okay. Tapi when the temperature increases, dia kata okay 5 degree it's cold but it's not really that cold. So dia dah mula jadi Y. Okay. And then 10 degree pada Johnny dia kata no, that's not cold. To me that is not the definition of cold. Macam tu. So dia dah letak N. So seterusnya semua kat sini dia letak N. Okay? Faham So nampak sini semua dia letak N. Okay, and then kita cuba describe cool dekat Johnny. Is 0 cool? No, dia kata that's not cool, it's cold. Alright, so dia letak sini not N. Okay, 5 degree, dia kata yeah, it's kind of cool. Okay, so dia letak sini. Why? Dia kata 12.5 degrees is definitely cool. Yang ni dia letak Y star. Okay, and then dia ada Y dekat 15, tapi 17.5 dia kata no, that's not any cool anymore. Dia kata dia dah tak sejuk dah kalau 17.5. Okay, and then the same goes here on pleasant. Yang pleasant dia kata dia suka set tu yang definitely je, dia kata yang lain tu dia kata tak berapa setuju. Kalau 15 tu dia dah tak pleasant dah, dia cool dia kata. Alright, and then warm, dia identify warm dekat 22.5. Okay, yang lain semua ni dia not kan. And then hot bila dia 30 degree. Okay, kita anggaplah ni Johnny ni Mak Saleh katakan. So bila dia Mak Saleh, dia punya daya ketahanan untuk sejuk tu tinggi sebab dia biasa dengan sejuk. Alright, so dia punya tempat dia letak Y star tu mungkin berbeza dengan kita. Kita orang Melayu dah biasa dengan cuaca yang macam ni. Okay, however Mak Saleh ni walaupun dia daya ketahanan sejuk dia tinggi, dia suka panas. So pada dia kalau 30 degree tu best. Dia suka panas. Kita dah biasa dengan cuaca ni, kita rimas panas berpeluh-peluh. So that's how it differ lah. Kalau you buat sistem, kalau you nak memuaskan hati user you, so you have to identify how does your user perceive your temperature lah. Okay, clear dekat sini? Bila you dah come out dengan yang ni, baru you plotkan dia ke dalam graph. Okay, ini Johnny punya perception of speed. Dia pasang kipas motor laju ni, dia kata yang mana, dia kata minimal, mana slow, medium, fast and blast. The same applies here. Cuma dekat sini dia punya variable adalah speed, which speed is measured by RPM. Okay, 0 sampai 100. Ni dia punya set dia, value dia. And then dia nak cuba apply kepada minimal, slow, medium, fast and blast. Okay, so dia identify dekat mana dia identify Y star dia. Gitu. Biasanya when you identify Y star, dia mesti ada grey area which is Y dekat sekeliling dia before you go to no. Okay, cuma dekat sini dia letak yang medium tu tak ada. Ada juga case yang tak ada yang case ada. Right? Ada yang case ada banyak. Macam ni ada 2 before dia kata no. Is it clear? Faham ke cara nak construct table ni?
Yes, faham.
Any questions on this one? Tak ada Right. So bila you dah ada yang tu, you mapkan dia ke atas graph. Okay, bila you letakkan ke atas graph, you akan dapatlah bentuk-bentuk graph ni. Okay. Yang mana Y star tu, yang Y star you letak dekat atas lah sebab dia definitely kan totally belongs. Yang Y star, kat mana dia Y star, you letak dia 1. Kat mana dia N, dia letak dekat 0. Maknanya yang tengah-tengah ni mesti dekat value dia Y. Dia bukan Y star. Y star yang dekat atas. Saya tukar colour bagi nampak. Y star yang colour ni pink ni. Yang ni Y star. So you plotkan Y star dulu. You plotkan N, di mana N tu first berlaku sebelum Y star. Yang tengah tu akan jadi dia punya Y. Okay. So Y tu akan jadi bentuk yang berbeza-beza lah. Yang ini mudah sebab you guna apa bentuk graph ni? What are the membership function? Which one? Is triangular, right?
Yes.
Yes. It's easier because it's triangular. But there are some cases that you cannot use triangular. For example, kalau you letak dekat sini, contoh je lah katakanlah dekat sini dia letak this is Y star, this is also Y star and this is also Y star. So dia punya graph takkan jadi triangular lah. It will become like trapezoidal. Okay. Kadang-kadang ada orang suka guna sigmoid. Okay, kalau sigmoid yang S atau Z function tu dia lebih smooth lah, dia tak tajam. Sebab bila dia sharp, bentuk dia sharp, kadang-kadang ada some parts dia akan cepat-cepat tukar kan value dia. So some system you perlu guna yang S function, some system tak perlu. It depends, okay, of your problem. So this is how we translate it into the graph. So you will get this. Daripada graf ni bolehlah you keluarkan dia punya function kan. Bila you keluarkan function, you boleh codekan function tu ke dalam sistem you. Okay. Right. So dia punya membership function dia beginilah. Dia dah lukis graf, dia come out dengan linear function dia. Dia keluarkan function gunakan equation yang dah ada macam kita belajar hari tu. Right. So the same goes applies to the fuzzy set SPE. Clear?
Yeah.
Ada soalan? Ini je kita nak cover for fuzzy set.
No questions as of now. Thank you.
Good. Yang lain okey?
Okay.
Alright. Okey, kalau okey, you study dulu benda ni sebab hari minggu depan kita nak buat quiz. Quiz 1 pun tak habis makin lagi kan. Quiz 2 pula. Quiz 2 akan cover topik fuzzy sets. Any problem with that?
Madam, nak tanya.
Ya.
Untuk test 2 tu, bila akan diadakan test dia?
Test? Kita tak ada test.
Oh, tak ada. Salah dengar.
Kita buat quiz je. Kita buat quiz je. Kita ada 2 quiz. Quiz 1, quiz 2. Memang kita cover the first 2 chapters topik lah. Yang first tu uncertainty kita dah cover in quiz 1. Fuzzy set kita cover in quiz 2. So the rest of the semester nanti kita cover dalam final assessment.
Okay, madam, thank you.
Yes.
On what day, Puan?
Monday.
Monday morning. Right.
Group A Monday morning, Group B Monday afternoon lah, pukul 4-6. Okay, kali ni quiz dia saya nak buat objektif 25 soalan. Tapi objektif saya tak nak bagi marking macam biasa. Saya nak buat negative marking, positive negative marking. Means that kalau you dapat jawapan betul, you will get 4 marks, 4 point. Tapi kalau jawapan you salah, markah you kena tolak 1.
Kalau tak jawab?
Kalau tak jawab, kira salah lah. Tolak 1.
Tak jawab dapat kosong.
Ya, tolak 1. Dia tak neutral sebab bila you tolak 1, dalam you tak dapat 4 markah tu, kena tolak pula lagi 1. So you hilang 5 markah lah sebenarnya kalau you salah.
Allah.
Okay. Sebab kalau buat objektif biasa tak mencabar lah kan. Lalek lah madam. Saya tembak je. Betul-betul lah.
Main game je madam.
Tak, saya rasa saya pernah, dulu saya pergi training dekat India. 4 months saya pergi sana. That is the way how they do the assessment. So saya kata kenapa dia buat macam tu. I found out tak bila dia buat macam tu, kita takut nak tembak. Sebab tembak tu akan bagi risiko markah akan tolak. Betul tak? Kalau tak, you rasa macam tak apalah, tembak je lah, dah tak tahu kan kita tembak je. Habis-habis pun tak dapat markah. So you akan pasrah dengan yang dah betul. But then you akan fikir lebih sikit lah. Sebab tak nak kena tolak markah. Tolak 1 je, you dapat 4.
Berapa soalan ni?
25 question, kalau betul semua dapatlah 100.
100 kan?
Tapi kalau salah semua negative 25 macam mana tu?
Negatif
macam mana?
Sudah lah. Dia punya carry mark
Maka
apa
quiz
tu,
1 negatif.
Nanti markah tu saya kena nanti kan kita punya 10% kan. Saya kena tengok dia punya percentage dalam range lah.
Oh, negatif carry mark lah, negatif.
Negatif lah carry mark dia. Tak adalah carry mark takkan negatif. Carry mark takkan negatif sebab dia nak ambil 10%. So saya akan ambil range lah. Dalam range tu. Dia kena dalam positive range. So saya akan normalize dia balik dalam range. So don't worry, jarang lah budak yang dapat negatif. Tak pernah kot. Sebab 25 tak pernah soalan.
Kita orang pernah je masa statistik yang satu.
Serius? Habis semua salah? Soalan
tak
susah
ada. Dia,
sangat
dia,
kot.
dia ikut emosi.
Sama Inah. Sama.
Tak ada. Soalan saya
Drama.
soalan objektif dan cover fuzzy set je. Tak susah pun kan. Macam tutorial hari tu saya tengok ramai dah boleh buat pun. Tak ada apa sangatlah, soalan senang je. Cubanya mungkin you have to be a bit careful. Mungkin dekat function kadang-kadang tu mana yang you kira dulu kan. Darab tambah tolak, tengok betul-betul lah. Tapi benda tu simple je.
Jadi makin susah kalau buat macam tu.
So objektif tu senang. Jawapan dah ada.
Aneh.
Don't worry lah, 10% je. But then saya percaya you all boleh buat.
Amin.
Amin. InsyaAllah.
Doakan kami, Adam.
Saya sentiasa doakan. Saya pun tak nak hadap you all balik semester depan. Saya nak jumpa tapi not in the same course.
Ya.
Okay. So, tapi biasanya fuzzy kita jarang lah dapat failure rate tinggi sebab dia straightforward, dia clear. Dia tak ada susah sangat sebenarnya fuzzy ni. Cuma kalau you fikir lebih sangat tu dia jadi susah lah. Kadang benda tak patut fuzzy, kita fuzzykan juga sebab saya nak fuzzy juga. So dia jadi pening lah. Benda tak payah fuzzy, benda tak payah susah, saya susah. Okay, so setakat ni saya rasa fuzzy set is not that hard. Sebab you tak start fire the rules, belum start nak construct the project lagi. Okay, about project, saya akan bagi juga next week untuk project punya kerja lah yang you kena start buat lah. Tapi group semua saya rasa you all dah form your groups, right?
Yes.
Dah, Madam.
Tapi saya tak nampak lagi lah. Senarai group tu saya tak nampak lagi. You all tak bagi kat saya lagi kan? You just decide on your own tapi belum bagi kat saya lagi. But it's okay. Identify lah apa masalah yang you nak selesaikan. Sebab sekarang kita dah cover sampai fuzzy set. I hope that you already have the idea what kind of problems that you are trying to solve. Okay, saya boleh bagi set of problems tapi pada saya it doesn't really fair for you because kadang-kadang kalau masalah tu datang dari saya expect solution dia mesti kompleks lah kan. Tapi kalau problems tu you yang identify, so you can describe the problem and how to solve the problem, it's easier for you lah because it's in your own creativity. Okay? Boleh je nak buat solve problem tu aircon ke, sama je. But then kalau aircon tak fair lah dalam kelas, dalam kita bagi contoh tu, takkan nak coding benda tu juga kan. Terpulang. So there are lots of things in this world that you can solve with fuzzy. So identify a domain that you want to. Okay? Boleh. Alright. So by next week saya nak bagi you punya the paperwork for the project. Tapi saya nak you dah identify your group. So next week saya akan sediakan Excel file. So you akan update the group members for your group project. Boleh and the domain that you're going to solve the problem. Simple domain je lah. Tak perlu lagi nak cerita what other problems and so on. Just the simple domain. Okay, katakan saya nak solvekan problem untuk rice cooker. Okay, buat rice cooker lah. Kalau tak nak buat untuk machines pun tak apa. Sometimes students want to do something like diagnosing system. Saya nak diagnose kalau orang ni ada masalah bipolar disorder contoh. The question might come from some questionnaire from a counsellor kan, a psychiatrist, mungkin dia ada that kind of question sets. And then daripada question sets tu mungkin you rasa ni boleh fuzzify, the value is fuzzy, little bit fuzzy here. Dia tak semestinya yes or no. It can be in between. So kalau you rasa macam you nak selesaikan masalah-masalah macam tu pun okey, tak ada masalah. Okay, so usually the problems that you are trying to solve yang menggunakan knowledge base lah. Macam you buat masa ISP568. Biasanya knowledge base. However, the difference are that the knowledge is no longer crisp, is more fuzzy values. Okay? Kalau nak guna balik projek masa ISP543 pun saya tak ada masalah. Tapi kena tunjuk dekat saya projek tu. Okay, tunjuk dekat saya so that we can see the difference. Okay, saya rasa Cik Iqbal seorang je punya, orang lain mana entah.
Ada je tu.
Tengah fikir domain nak buat apa.
Ada daripada insyaAllah.
Tengah fikir. Dia sama grup dengan Iqbal. Iqbal dah tolong jawab Okay. Alright. So take your time to study the fuzzy sets and then kita jumpa hari Isnin. Saya bagi link untuk the quiz
Alright, madam.
Okay.
Thank you.
Ada soalan lagi?
Ya ada. Pakai India.
Tiada, enggak ada.
Ya ada.
Okay.
Ya madam.
Right, kalau ada apa-apa you all nak tanya boleh tanya dekat dalam grup WhatsApp Okay, Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Jaga diri madam.
Thank you, madam.
Thank you, madam.